So my protein project was on Piezo with a mutation. Arginine 2456 is replaced by Histidine. And Piezo is found in a non-sensory tissue and helps cells sense local changes in fluid pressure. This function is useful in the process like blood flow because it helps gives us our ongoing feeling for how our limbs are positioned. They are essential in regulating psychological processes such as blood pressure regulation, vascular remodeling, and just bear with me one moment. Chondrocyte megacon transduction. And I would characterize Piezo as a receptor protein since it receives cations. However, you can argue that it could be a transport protein since it is placed in the cell membrane. Piezo is primarily found in non-sensory tissues, with majority being found in the lungs, bladder, and skin, in a subcellular and on a subcellular level in the membrane. Types of cells that carry this protein are skin cells, excuse me, blood cells, muscle cells, keratinocytes, endothelial cells, and also predominantly ligament cells. Types of organisms that carry this protein are ones with eukaryotic cells, mainly humans. This protein becomes more active when the mutation occurs, since it becomes slowly inactivating which then causes the channels to close, which means more calcium is going through the protein, and this mutation forces the beams to close slower. So I'm going to show you my my 3D model. I made my model out of fuzzy sticks. So right here you have at the top you have the caps, and the yellow swirly parts are the channels, and these are the orange and purple parts are the blades that stick out, and these pink and yellow parts are the these are the beams. These are the beams they have. So you can kind of see for a better view. Again, you got the cap at the top. You have the blades sticking out. You have 3 of them. You have the channels right here, and then you also have the pink and yellow part are the beams. And so that's where when they talk about the beams are slowly closing, they're slowly closing. The mutation forces them to slowly close, so they don't close as fast, which allows more cations to come in, and also more calcium to come in, because now it's open a lot longer before the mutation. So the main functional groups present on the amino acid side chain before the mutation, there's a carboxyl group and amine group. And the amino acid side chain is hydrophilic and is also positively charged due to the hydrogen bonds over there. And I would characterize this as being large compared to some other amino acids. So, when it is mutated, on the mutated side chain still has that same carboxyl group and amine group, and there's the mutated amino acid side is still hydrophilic due to the hydrogen bonds, but in some stages it does become, excuse me, hydrophobic. And the mutated amino side chain is still positively charged, and I still researched that the amino acid side chain is still relatively large. So the differences in the types of interactions that the mutated amino acid side chain can participate in compared to the original amino acid is it can form hydrogen bonds and ionic bonds. Unlike arginine, Histidine can be positively charged or negatively charged depending on the pH. And I'm going to get a little bit more in depth with the protein. So how does my mutation affect the protein function? The mutation leads to Piezo 1 protein being slower to react to pressure change, and close of the channel leads to overactivity in the protein, allowing excess calcium into the channel and then into the blood cells, and then the cell can become dehydrated and gaining hemolytic anemia, and it causes the organism, or in this case the human, to experience fatigue, jaundice, and also darkened urine. So when the mutation happens, it affects the channels, making, well, the beams also. The beams are slower in closing, so this allows the channel to intake a lot more calcium, affecting the cell. And just a little bit more information, because of the mutation, the beams are slower to close, like I said before. So usually they will open it and close, but because of the mutation, they close a lot slower, letting in more calcium that's not needed in the cell. So for the main function group on the original side, for the main functional group in the original side chain of Arginine, it is a complex side chain of mostly hydrogen carbons, and amine group. Because of the nitrogens in the side chain, is considered one of the most hydrophilic amino acids, because it includes a large quantity of guanidine and can make up to 6 hydrogen bonds. Arginine is polar covalent and positively charged. The amino acids is one of the bigger ones found in the chemical structure. Since arginine is hydrophilic, it can interact strongly with water and form hydrogen bonds with other hydrophilic side chains. Arginine can also form ionic bonds because it has a positive charge. And the mutation, they don't. And the mutation requires a arginine be replaced with a histidine. So when the mutation happens, arginine is replaced with histidine. And I'm going to get into more what happens when histidine comes in. So histidine is very similar to arginine. It has a side chain of mostly carbon, hydrogen, and a carbon ring with nitrogen, making it have an amine group. So just like arginine, histidine is polar covalent and positive, and only slightly bigger because of it having a ring. Histidine can also form hydrogen bonds and ionic bonds because it's properly covalent and positive. Also, histidine can exist as positive or negative, this depending on the pH range. And then I already talked about what happens when the mutation occurs. Of course, I'll reiterate it. The mutation leads to the Piezo 1 protein being slower to react to the pressure change, and close of the channel leads to overactivity in the protein, allowing calcium to enter the channels. These right here, the channels, into the blood cells, which then the cell can become, of course, dehydrated and gaining hemolytic anemia, and it causes the organism cells to experience fatigue, jaundice, and darkened urine.